Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, here we are ready for the next lesson. This lesson and the next lesson are the last two lessons of Chapter 2. We're going to kind of take a little departure away from what we've been learning so far. We've been learning about how to deal with fractions and multiplying fractions together, portions and mixed numbers. Oftentimes at the back of a chapter, we often have some isolated units and concepts that maybe fit in with the chapter, sometimes they don't. And this particular one really doesn't fit in with what we've been learning for the rest of Chapter 2, but it's okay. We're not going to dedicate an entire chapter to this, so we're just going to throw in a couple of lessons. It's called Choosing a Scale, and this relates directly to work that we do with coordinate grids. Now, we're not going to do this as much in 7th grade, but in 8th grade math, we're going to spend a fair amount of time working with graphing. And when we get to data and statistics, we are going to be looking at situations where we've got two variables, a dependent and an independent variable. And we're going to look to see if there is any sort of correlation between the data, and then use that data to draw conclusions about a certain situation. What we're doing today is sort of a foundational piece to help us be more successful with what we're going to be doing in 8th grade and then eventually in high school. So what I'd like for you to do is I'd like for you to draw a coordinate grid, but you don't have to worry about the, just draw like an L graph. The coordinate grids have 4 parts to them, but this is the part where we do most of our work for data and statistics, because if this is the origin 0, 0, and everything on the x-axis to the right of it is a positive number, and everything above the origin on the y-axis is a positive number, and that's where most of our work takes place. So this is like quadrant number 1. It is the most common one, and a lot of times when we create graphs, it's just an L shape instead of your traditional 4-quadrant graph. So all graphs have to have a horizontal axis and a vertical axis. The horizontal axis is the x-axis of the graph. It's a number line, and all the x values are going to go on this axis, okay? The vertical, or actually I should say all the x values are going to reference that axis. The vertical axis is the one that goes straight up and down. That's what vertical means. And so we sometimes call that the y-axis. It's also a number line on the coordinate grid. Now, notice how scale, which the scale is the counting sequence for each number line. Sometimes when we do coordinate grids, we have the scale be the same for both the x and the y-axis, but they don't have to be. Sometimes, your x-axis you want to count by ones, but your y-axis might refer to something like the the cost of a pizza. Maybe if a pizza costs $10, one pizza is 10, 2 is 20, 3 is 30, then you'd want to have a different scale for your y-axis than you would for your x-axis. So there's no rule that says they have to be the exact same. The only rule is if you actually extended your x-axis out into the negative region, you'd want to be counting by ones there as well. And if you take the y-axis down below into the negative region, there you'd have to be counting by 5s as you are on the top. So you can't change the scaling on either side of the origin. It always has to be the same for the entire horizontal axis and for the entire vertical axis. Okay? I guess one more thing that we can throw in there, I'm sure you've got some experience with this, but when you plot a point, they are ordered pairs, right? So you can take a point 2, 15. And this is the x portion of your ordered pair. The first number is always the x, and the second number is always y. So we would plot that as find the x value first, always start at the origin, go to the x value first, which is 2, and the y value would be 15, 5, 10, 15. We can label that point. And that's how you plot points on a coordinate grid. You've got both your X and your Y points that you're plotting at the same time. So each one of these references their respective axis. All right, so graphs can be useful tools for finding relationships and making predictions. In this lesson, you will work with your team, or you will work on your own and listen to me, to make choices about how to set up a graph in the most useful way, depending on its purpose. As you work, use the questions below to help focus your thoughts. Does our data fit, and can we see it clearly? Can we make it clearer? How can we make a prediction, and will a different choice make it easier to predict? Okay, so this is our topic, Peyton's bats. Peyton loves bats. She wants to know if she can predict the wingspan of a bat by knowing its body length. This is a very scientific inquiry. This is the types of things that scientists do. Peyton looked at measurements for 5 species of bats. For each species, she found the typical length from head to tail and the wingspan, which is a measurement from one wingtip to the other wingtip. She organized the data in this table below. So bats in Tennessee, they have a lot of caves in Kentucky and Tennessee in the Appalachian Mountains, and I imagine they have a few bats there. So here is the data, and you should copy this entire table down. Do not move forward until you've paused and created. It's got 1, 2, 3 columns, and it's got 1, 2, 3, 4, 5, 6 rows. The top row are your labels, and you've got 1, 2, 3, 4, 5 different bats. Okay, so go ahead and get that copied in, and then I'll move to the next page. You can unpause when you're ready. Okay, so you've got this all written in your journal. Now, Peyton has started a graph. This is the graph that she started. There is a resource page for this. I have attached it to the classroom. So if you want to print that off, you may. If you don't have a printer at home to use, you can just draw the L kind of graph here. But please be careful. If you've got graph paper, it makes it so much easier to make sure you get everything spaced out perfectly and straight. If you try and do this on regular lined paper, you can use the blue lines for your y-axis, but you've got to make sure that you get every single one of these tick marks perfectly spaced on your x-axis, and that's not easy to do. If that's all you've got available, just do your best, okay? But if you've got graph paper, use graph paper. If it's much, much easier to print this resource page, and then you can cut out these graphs and glue them into your journal, that is perfect too. Okay, so which axis represents the length of the bats, and which one represents the wingspan? So here we've got 1, 2, 3, 4, 5 points. Those points are for the ordered pairs that are created from these numbers. Okay, so if you thought of this as 5, 14, like we did with that with the 215 I had on that opening page, then this would be the x-axis, and that would be the y-axis. But you could also flip them around and make the x be 14 and the y be 5. So the question is, which one is it? Which of these are referencing the x-axis, and which of these are referencing the y-axis? Can you tell just by looking at the graph? Well, do you notice that the bat lengths, none of them go beyond 5 inches? So if you look at your x-axis, are there any points that go past the 5-inch mark? No, there aren't. Are there any points that go beyond the 5-inch mark in the y-axis? Yes. So it really looks like, what is that, 14, and this one is 12, and this one is 11, and those are 10. That appears to match what we've got here. So that tells me that these are the y's. Remember, this is the y-axis. She didn't label these, so I'll do it for you. This is the y-axis here, and this is the x-axis. And these must be our x's. So that answers our first question. The x-axis is for length, And the y-axis is for wingspan. Okay, so what is the scale of the horizontal axis? That is, what's the scale? What are they counting by on the x-axis? In other words, blah, 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 blah. And then what is the scale of the y-axis? Can you see what they're counting by? Now, I want you to be careful here because each one of these tick marks needs to be accounted for. That's what we're scaling. So even though they only labeled the 5 here and the 10 here, this is the 5th tick mark. 1, 2, 3, 4, 5. So that means that we're counting by ones here, right? Here it takes 1, 2, 3, 4, 5 tick marks to get to the 5 as well. So that means we are counting by ones, or Peyton is counting by ones for both the horizontal and the vertical axis. This is also a pro tip. When you are creating your coordinate grid and you put in those tick marks, you don't have to label every one of them. You know, if we go back to what I did here, I didn't label this is 1, this is 2, this 3, this 4, this. In fact, I could have done it this way. All you need is one number to know what the scaling is. I could have put just the number 5, 1, 2, 3, 4, 5. I could have just put it right there, and you would have known that we were counting by ones there. Because if the 5th tick mark is 5, then every single one of those must be ones, or a distance of 1 apart. Okay, so back to our last question for this particular problem. Peyton wants her data to spread out so that she can see relationships clearly. Does this graph allow her to do that? Are there any changes she could make to make it a little bit clearer? It does look like it's really clustered in there. You've got all this space out here to work with. Doesn't it seem like if we could just work with that space and spread these out a little bit, it would be a little bit easier to draw some conclusions, especially like right in there where you've got 2 of these bats that are, their points are so close together, it's kind of hard to tell them apart. So by changing the scaling of the x-axis, or of either axis, really, you could stretch it up in this direction as well. Maybe you can get it so that it's a little bit clearer. So Peyton has an idea. We'll make the numbers on the horizontal axis bigger, she says. That way the points will be more spread out and easier to see. So do you see how now she's got a 10, 20, 30, 40 here? She's not changing the vertical axis, only the horizontal one, because she wants to stretch it out this way, okay? What is she counting by there? How many steps does it take to get to the number 10? It takes 5 steps. So she must be counting by 2s, right? 2, 4, 6, 8, 10. So how has she changed the scaling? She's now counting by 2s instead of counting by 1s. Will Peyton's new graph be more useful? Okay, so now what you need to do is if you've got the resource page, you can use the next graph over for problem 108. And I believe the scaling should already be in there. Let me actually go check that. This is what the resource, yeah, so you can just use this one right here. You don't have to worry about creating a new graph. Whereas if you're creating them on your own in your journal, then you are going to have to create a new graph. Please do not put it over the one that you've already created. Okay, so after you've done that, once again, go and plot these points. Unpause when you're ready to see how I plotted those. Okay, so let's see what the graph looks like. Does this help the situation? And I think no. It actually makes it worse. They're scrunched in more. Her goal was to spread them out further, and she actually now has them within the first 2.5 to 3 lines here on your tick marks of your x-axis. So no, this is not a better situation. So instead of counting by 2s, maybe she should have gone in the other direction. What if she counted by like halves or quarters? Okay, we'll see what effect that has on our data. So you can decide, but I'll give you a little hint. I decided to have every 4 tick marks be a be 1. So for this next one down here, so you've got room here to go 1, 2, 3, 4. So this would be 1, and this would be the 1/2 mark. This would be 1 1/2, and this would be 2. There's enough room to fit that in there to count by quarters. But if you want to, you can actually count by halves and say this is 1, and this is 2, and this is 3. You choose how you want to do that. It doesn't make any difference to me which way you decide to go with that. Once you've done your scaling where you've made your scaled line either counting by halves or by quarters, then plot those points in again and see if it doesn't spread it out a little bit more. Okay, unpause when you're ready. Okay, so here we go. I'm going to take away this, and this is going to be my graph. So the length, I decided to count by quarters. So this is 4 steps to get to 1. So 1 1/4, 1 1/2, 1 3/4, 2, and so on and so forth. I was able to get all of the bats in with their lengths. It just gave me enough room to get to the big brown bat that has a length of 5 inches. Okay. So can we draw some conclusions from this? Notice how most of these bats fall within kind of a straight line, kind of an idea with the distribution of their points on the coordinate grid. There's only one that looks like it's an outlier. This is what we do when we're trying to find association between data that has 2 variables, an independent and a dependent variable. Is one affecting the other? You'll notice if it seems to form a line or falls kind of close to following a straight line, that means that there is a correlation. And the correlation that I'm seeing here is that longer the bat's body is, longer the wingspan tends to be. The only exception to that is this guy right there, which appears to be an outlier. Okay? If you had points all over the place, you would say that it's impossible to draw any conclusions. But 4 of the 5 points do tend to follow this line, which means that there is a significant association between the bat's length and its wingspan. Okay, so the longer the bat, the longer the wingspan tends to be, with the exception of this guy right there. That's the one outlier. So with that in mind, we can now make some predictions. It might be a good idea if if you don't have your graph looking like mine, and yours was all over the place, maybe fix it so that it looks like mine, and then use your ruler to draw that line that goes through there. This is what we refer to as a line of best fit when we're doing this work in 8th grade. Okay. So now, Peyton found more information about bats. In parts A and B below, you will use the information she found to make predictions about these 2 other bats. So these 2 other bats, one of them is called the common vampire bat. Okay, and it's native to Mexico and Central and South America. It feeds on the blood of sleeping cows by making very small cuts in their skin and then licking the wounds. Hopefully you're not doing this late at night and you're going to be going to bed and having nightmares anytime soon. I apologize, but bats got to eat. Everyone's got to eat. So yeah, be happy you're not a sleeping cow in Mexico. Use your graph of bat length and wingspan to predict the wingspan of the common vampire bat if it typically has a length of about 2.75 inches. Okay, so it typically has a length of 2.75. So we had length on our x-axis, correct? So I'm going to code this one green. Where is 2.75 on my 2.75 is right around there, right? So this most likely, if it follows our trend with the other bats and isn't an outlier on its own, right? Remember this guy was the outlier? Assuming, you never want to assume something is going to be an outlier. You assume it's going to fit within a range of all the others. And so I'm just going to place it right on the line of best fits. And what is the wingspan for a bat that appears to have a length of 2.75 inches? I would say that's about 9 inches, correct? So we can predict that the common vampire bat should have a wingspan that is in the 9-inch range. Plus or minus, I don't know. We could get, when you get into higher levels of data and statistics, you can talk about margins of error. But right now, let's just stick with a prediction for, and just call it 9 inches. The Kitti's hognose bat, also called the bumblebee bat, is the world's smallest bat. Now I'll go ahead and bumblebee bat. I'll call it the Kitti's hognose. It lives in Thailand and Myanmar. It weighs less than 1/10 of an ounce, which is less than a penny, and is only about 1 inch long. Okay, so now let's do the exact same thing. Let's see if we can make a prediction for 1 inch. Where would this guy go? 1 inch, 1 inch. Does it look like it's going to be somewhere around there? So I'm guessing that this one probably, as long as it's not an outlier like the Brazilian free-tailed bat, this one should fall within a margin of error of that line, and we expect this bumblebee bat to be somewhere in the vicinity of 5 inches for its wingspan. Okay, so this idea of using coordinate grids to plot points that are given to us or plot data, we can look for patterns in the data, and we can draw conclusions about the data, and then we can use those conclusions to make predictions about other things that we're trying to solve, other things that we're trying to figure out. Okay, so how much time did we spend on that? 21 minutes, not too bad. Okay. Do your homework, be prepared. You're going to be getting lots of questions about interpreting graphs, plotting points. Well, not a lot of questions about interpreting them, but a little bit. More than anything, we're going to be working on scaling in 7th grade to prepare you for the 8th grade work we're going to need to do. All right, take care.
Hey, feeling